Okay, so sorry. Take two. So capacity, how much liquid a container can hold. If you think about this particular container and you compare it with a swimming pool, you will quickly say that this has less capacity than that swimming pool that has more capacity. So the swimming pool can hold more liquid in its container. Something else you'll need to think about is liquid volume. So that's what we're measuring, is how much space liquid takes up. We're going to do so using the metric system. If you use the customary system, which is something that most of us are familiar with when we are thinking about cooking, for example, we use quarts, gallons, which is the biggest, gallon, quarts, pints, cups, and finally ounces. We use a lot of that in cooking, but in math, in science, and most of the rest of the world, they use liters and milliliters. So if you take a look, it's very similar to what this looks like over here, right? 1 liter, which is the larger unit, 1 liter can be represented by this giant 10 frame. And what we did was we decomposed that 1 liter. We were trying to prove that 1,000 milliliters, so that lowercase m, capital L for milliliters, and capital L for liter, that 1,000 of those milliliters fit inside 1 liter. So we decomposed this into 10 equal groups. So 1 liter, 10 equal groups, we made 100 milliliters in each of those groups. Then they asked us to decompose even further. They said, okay, well, if you decomposed 100 milliliters into 10 equal groups, what would that be? So then we did it. We used a 10 frame here. We said 100 milliliters divided by 10 equal groups is going to give you 10 milliliters in each of those groups. Finally, what we did is they wanted us to know how many milliliters are in 10 milliliters. Well, how many would be in each of those units if we divided it into 10 equal groups? So you took one of those units and you divided it up into 10, and then you colored one in and you have 1 milliliter. The point being is that if you counted up every single one of those milliliters, it would equal 1,000 milliliters, which then equals 1 liter. So if you go over here to what we were looking at before in our glassware today, you can see a little bit more of what I'm talking about. So this glassware right now is equal to 1 liter. It's also equal to 1,000 milliliters. And so what we did, we actually, instead of decomposing this 1 liter, we composed, we put it together. So we were multiplying things. So what first we did was that we took 10 of these flasks and we had 100 milliliters in each of those flasks. But in order to start from the very beginning, what you would have to do to get 100 milliliters in there is to take this pipette. And if you see really, really close up, I don't think you can see, but this is the size of 1 milliliter. So you would have to put it in water, suck that up just to about here, and then drop that milliliter in, and you'd have to do that 100 times for each of the flasks. So it would take a very, very long time. Let's just say that. So here, imagine that we did that. 1, 2, 3, 4. This is 100 milliliters. 5, 6, 7, 8, 9, and 10. So we filled, they were all filled up, all 10 of them. And then what we did one by one is we poured them into this. So we proved that 100 milliliters dumped into here 10 times gives you 1,000 milliliters. And another way to say 1,000 milliliters is 1 liter. So that is what we did today. Something else that I think is probably important for you to know is what it looks like on the outside when you're measuring using something like this glassware, right? So the reason why it's vertical as opposed to horizontal is because if you had this horizontal, what's going to happen, right? All the liquid's going to come out. So in order to have it so that the liquid doesn't come out, we've got this number line that we're using, but it's actually going vertically and not horizontally. So they're just asking you in some of your problem sets to look at that number line in a different way, different position. So usually we look at it like this, but now it's flipped to vertically when you're dealing with something like volume with liquid. Okay, I believe that's it. What I would highly suggest is that you take a look at the customary system as well, because that's generally what we use when cooking, and kind of see the difference between quarts, pints, cups. What else am I missing? Gallons. The gallon's the big one. And see, you know, if you start with something small like 8 ounces, how many ounces fill up a cup? How many cups fill up a pint? How many pints fill up a quart? How many quarts fill up a gallon? And then you could even compare and say, okay, well, I have 100 milliliters here. Does that compare? Does it look more like a cup? Does it look like a half a cup? Just so that you could get an idea of, you know, how you can compare them and convert them eventually. Okay, thank you.